you have worked out the number of subatomic particles in an atom, you can then draw it. Begin by drawing the nucleus in the middle. And remember, the nucleus contains protons and neutrons. So you just write down the number of each in there. So potassium has 19 protons and 20 neutrons. Then you want to start adding electrons. Remember that electrons orbit around the nucleus and electron shells. But the problem is, each shell can hold a limited number of electrons. This first electron shell, the one closest to the nucleus, can only hold 2 electrons. And we'll draw our electrons as little dots. Since potassium has more than 2 electrons, we need to add another shell. This second shell can hold a total of 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So now our drawing has a total of 10 electrons, 2 in the first shell, 8 in the second shell. Potassium still has more electrons than that, so again, we need to add another orbital. This orbital can also hold 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So now I've drawn a total of 18 electrons. Potassium still needs 1 more electron to bring it up to 19, so we need to draw in 1 more shell. With 1 electron in it. So potassium has 19 protons and 20 neutrons, which we write in the nucleus. Then the electrons are orbiting around. The first shell has 2, the second shell has 8, the third shell has 8, and that fourth shell has 1. And we can summarize that by writing the electron arrangement. So the number of electrons in each shell. So the first shell had 2, the second shell had 8, the third shell had 8, the fourth shell had 1. And that brings us up to that total of 19 we needed. Now it's your turn. Pause the video and have a go at drawing the aluminium atom. So the number of protons, neutrons, and electrons have been calculated already. You just need to draw it and work out the electron arrangement. All right, let's go through it together. So inside the nucleus there, we have our protons and our neutrons. So 13 protons, 14 neutrons. Then around the outside, we have our electrons. So the first shell can hold 2, but we still need more than that, so we add another shell. And this shell can hold 8 to bring us to a total of 10. So let's add in those electrons. Tahi, rua, turu, pa, rima, unu, fitu, waru. Okay, total of 10 electrons, but we needed 13. So we add 1 more shell, and in that shell, we're going to have 3 electrons. So tahi, rua, toru. So that gives us an arrangement of 2, 8, 3, which gives us a total of 13 electrons. So that's the aluminium atom. All right, here are some summary notes for you that you may want to have a look at while you continue to do a little bit more practice.